Yes, sir. Welcome back, sir.
Thank you, sir. Thank you very much.
I'll put this notice on the WhatsApp also.
Right. So you're able to see my screen, sir?
Yes, sir. Yes, sir. Very nice, sir.
Friends, I hope you are able to see the screen. And we had taken a break at this particular point, juncture, where we were trying to design a system to monitor the air conditioner values, right? I need to just, can anybody just switch on the mic and let me answer me the things?
Yes, sir, I can.
Yes, please. Yes, please. It will be easier for me to actually discuss this with you regarding. So I hope you have designed this, the temperature, humidity, and the cooling part, the two inputs and the output.
Yes, sir, it is done, sir.
Great, great, great. Now we move on to the next window. Now you can see this next window over here. This was for variables. This is for rules, right? And rules would comprise of, again, the linguistic variables that we have just designed to actually see how these linguistic functions can be taken into account for, and how the system or the fuzzy controller can be designed, right? So let's do this. So add a rule. If temperature is high, then cooling is high. You can change this. If temperature is high, antecedent you need to press again. Humidity is also high, right? Or say humidity is medium, then cooling should be high. I hope you agree with this.
Sir, can you just repeat, sir? I could not.
I'll remove everything. Rules,
Yes.
just click on to the add button, you will see a rule. If temperature is high, cooling input that we had selected humidity. So you need to press the plus on antecedent. So we'll see. Now, if temperature is high and humidity is medium, then what happens? Can you see this? I hope it is clear. This is the first rule only. You press another second part, the second rule would come. Press plus to this. So if temperature is now say moderate, humidity is high, then again cooling should be high, right? We assume this. Press another plus, antecedent to this. If temperature is say medium, humidity is still high, the cooling should always be high in this case, right? Press another rule. If temperature is low, the humidity is medium, or the cooling should be moderate. This is what we want to say. Again, press another rule. This, so temperature now is high, but humidity is, or say temperature is say medium and humidity is low, so the cooling should be moderate, right? So we can design all these rules accordingly. Say I have designed almost 7 to 8 rules for myself, right? It is moderate, and this is humidity is low, so it can definitely be also low in this case, right? So I hope everybody can design this. Have you done this?
No, sir. Actually, your mouse speed is faster than means we can actually grasp.
Okay. No problems. You still use this plus to add the rule. Again, I'll tell you, right?
No, sir. Actually, we got the point and concept, but
Okay,
to
okay,
do.
okay. You can do it. You can do it. I'm waiting. I'm waiting.
Yeah, yeah, sir. Okay, sir. Give us the minutes.
No problem.
Sir, actually, we should rename it, right, sir? That is the high, medium, low for temperatures.
You can do it. You can do it. That is what I'm saying. Again, see, it depends on the designer. I'm just trying to tell you, right? Now, you could have taken something else for temperature or humidity, or for say a fan speed. You could have taken in this rather than cooling, right? And
Yes,
you
sir.
can design. You could have designed. I'm just trying to show you how to design the system, right?
Yes,
Now you
sir.
have designed some rules and you have added the antecedents also. While we move to more complex systems, I'll be using further rules in this. Now, once you've done this, I hope everybody has designed. So, if you can, in what I was trying to tell you in the block diagram, and can you see this and here? So, if then else rules are being used. If temperature is this and humidity is this, then what happens? What is the output, right? This is how and is used. Antecedent, right? Types of consequence in the product. I'm using the minimum part right now, and I have the defuzzification method also over here. If you can see the defuzzification method, yeah, modified center of, and all these over here. This is what I showed you in the presentation, that we will be having some defuzzification method, right?
Sir. Hello, sir.
So you need to select yes, please.
So this is Raghav. Sir,
Yes, please.
I'm here in antecedent connective.
Okay.
Hello.
Yes, please go ahead, sir.
Antecedent part, I can see two options with and bracket minimum and bracket product.
Product.
So
Right.
we
So
should
there
go
are
for
two.
product, right?
You can go for product also, but right now I'm using and minimum only, right?
Okay. And sir, one more request, sir. Sir, if you can
Please.
turn off your video, then it will be helpful for us because
Okay.
it will help
I'm
us
sorry. I
preserve some
didn't
bandwidth.
recognize that the video is there. Right now, is it okay?
Yes, sir.
Yes, please. Right. Thank you very much for pointing that out. Now, great. So I hope you've designed these rules.
Yes, sir.
Great. Now what you need to do is, because you've designed these rules, you need to select the method here. I've just selected center of area only right now. You can select center of sums, you can select center of maximum, whatever you want to do, right? So accordingly the classification will be done and the crisp output will be generated. Now how do we do it? How do we? This is because this is a fuzzy system designer. It is providing you all the things in within one window itself. Now go to the test system, right? Can you see this test system over here?
Yes.
Great. Now what you need to do is temperature and humidity. You can see both these values, right? So when I click onto the humidity and temperature and the output cooling, now what you need to do is you need to just move these axes, see some values being changed, and you'll see some rules coming out. You see those rules with the gate? This is for the testing. 5 and 7, these are the two rules that have been selected. Say, because output variable will move accordingly. right? Can you see this happening? Now the rule have changed 2 and 3, and the output here is also changed. If you can see this.
Yes,
Just
yes.
move. You have to just move this. At this particular point, no rule gets selected. That means it was not the function that was analyzed. So 5 and 7 is the one output that we are getting according to what we have just set, right? And 2 and 3 is another output that we are getting out of this. You can change this also. You can change this also, right? Again, you can change the temperature. You can see 2, 3. There is one location where you get only 3 over here. And say I use humidity. Now you can see the addition of rules happening. Now this is the output. How easy it is, right? 4, 5, and 7 according to these values. Now this will change, and you can see the change in the output also happening. Now 1 and 6 have come into picture, right? Now this is the controller output that we have designed. This can be measured, this can be viewed, right? And this can help you out analyze a very complex system also. Right now, we have just utilized a very simple system in picture. Have you been able to do this?
Yes, sir.
Is it interesting?
Yes, sir.
Right. Now if you see how easy it becomes for us. This complete system, one system, is helping us to analyze, view, and design in a singular fashion, right? I hope you can see this. You can change them together also. Right? If I change the temperature and I move this, now what happens? So it is producing some rules. It's producing some rules for some outputs. So output cooling is getting changed accordingly, right? Now, however complex the system might be, the only thing that we need to do is we need to correctly plot the rules for us and analyze the system, right? Now, because we are talking about fuzzy system designer, we are talking about some fuzzy applications. I'll be I'll be showing you many more applications that can be designed using the fuzzy system designer or the fuzzy control, right? But this complete structure, this fuzzy, because you all are having this in your systems, the fuzzy system designer, you can definitely solve any of the problems accordingly, right? You can even use a 3D plotter, right? You can change these values, you can change the colors, whatever you
Sir,
want.
where did you get that 3D graph properties?
Right click onto this.
Okay, sir.
Right click onto this 3D graph properties, right?
Okay, sir.
Plots, axes, values, formats, whatever you want.
Yeah, got it, sir.
Great, great. All right, so we move ahead. Now what I'm trying to, because we have spent some time to analyze this system and how to use it. Now this was the one. Again, if you compare it with the chart that I've shown you, fuzzification, composition, implication, and aggregation. Can you just all see these steps? Right? The membership functions, the rules, the antecedents, the consequent implication, whatever you want, you can change this also. Now you move to the test system, the outputs would definitely change accordingly, right? Say I change it to here. So you see some different types of outputs, right? So you can change these. Consequent implication, then what type of defuzzification method you want to use, right? So what type of defuzzification method am I using? I'm using this kind of a defuzzification. You can see this. The red line that is coming is actually showing you what output is being monitored, right? So cooling output value is also shown in that window. What cooling output value should we use? I hope you are getting this. Right, friends? Are you? I hope you've understood this. Can I just close this out and we can move ahead?
Yes, sir.
Yes, please. Please. Thank you very much.
So we'll just save it now.
Yes, sir. You can save it. You can save it. Yes, yes. You can save it. Save it from here. Save as, and you can give it a name, and you can save the system that you have designed. Right? I have to follow this. There's another option over here. If you can see, you go to rules, and what I'll do is clear all the rules over here. Okay, I've cleared all the rules. There's option pre-generate some rules. Now it has pre-generated the rules for me. Can you see them?
Means has it automatically generated them, sir?
Yes, yes, yes.
Okay, sir. I think you should have said it before so that we can implement. Actually, we saved it,
No,
sir.
no problem, no problem. You can open it and you can again use this pre-generate all the rules. Click onto this, right? And you will see the rules being generated. Now the test system is in front of you, right? So according to
Yes, sir.
those pre-generated rules, the output would also change. I hope
Yes,
you can
sir.
see this, right?
Yes, sir. We can see it, sir.
Yes. So this was another addition to the fuzzy system designer that we're using. So easy part is you clear all the rules and you go to pre-generate rules. This is the thing that has been done. And product, all things are there. Consequent is also there. So whatever you want to use, you can just click onto this. How many rules you want, how much degree of support you want, right? So either it is 0 or 1. So you can even just use them and analyze your system accordingly. I hope you followed this now.
Yes, sir.
All right, friends. So I think we can move ahead now.
Yes, sir.
Great, great. So what I'll do is I'll just switch this. I don't want to say this, right? So now we move ahead. We move ahead into what exactly what we want. So I've already explained this. The point is that we want to design a particular system. Say I have taken an example of a greenhouse system for all of you. So how we'll be doing this? I'll be telling you how to design this greenhouse structure. So the motivation behind this is again, as I told you, we've already talked about a lot now about fuzzy logic. So the motivation is to use the energy resources very well. That is to reduce the power consumption in the fuzzy logic system, to effectively ensure that the farmer who is even illiterate is able to utilize the features of artificial intelligence and the fuzzy logic together, right? So this is the main thing that we want to do. Now everybody can use this, right? If you see, uh, all the things are done inside the system. A fuzzy controller is designed, the system is prepared. The only thing that a person needs to do is just control the knobs. And even those things can also be. I'll show you how a complete artificially intelligent greenhouse system can be designed effectively. So I hope you are able to hear my voice clearly, friends.
Yes, yes.
Great, and I hope you are enjoying the things that we are doing. Because until and unless you enjoy things, it is of no use for us.
Yes, sir, we are enjoying.
Yes, yes, yes. That is the main part that I wanted to ask, and only one student has answered or one participant has answered. So rest, I don't know whether they're enjoying it or not, but still, you need to enjoy this, right? To learn this, you need to enjoy this. Then only you'll be able to develop your own systems. So we are talking about a very effective system here, a complex system in nature, very complex in the
Sir,
case. Yes,
sir, I
please.
have a question. Sir,
Yes,
here
please.
in fuzzy logic system, sir, here we are only using if else statement. Like we are explicitly telling that what if this condition arises, then what to do.
Then what to do?
There
Yes,
is
yes.
no sign of artificial intelligence.
No,
Will
no,
we
no.
be doing it?
See, this is one of the artificially intelligent technique only. I don't know how you haven't understood this right now, but this is basically an artificially intelligent technique which is actually utilizing the features of if then else statement. Right? I'll tell you
Yes.
how. I'll tell you how. I'll show you a system and then you'll see how artificial intelligence comes into picture. So I'm using that system for you. I'm
Yes.
using a greenhouse. I don't know how many of you know what greenhouse is, but I'll tell you. I'll tell you how to utilize this system for the benefit of everybody, right? So what we'll do is we'll talk about this greenhouse controller now to be developed using the fuzzy logic. And if you see, what we have is we have two types of inputs being utilized in this. The two types of inputs that we are utilizing are there are three inputs in that case, not two: temperature, humidity, and solar radiation. Right. So these are the control inputs for a greenhouse. So what we need to do for a greenhouse is it is a structure, an artificial structure, which basically has controlled growth of plants. Right. So what we are talking about is we are talking about controlled growth, and we are talking about some living organisms, living structures being monitored, right? So a very complex system, I'll tell you. The fuzzy controller, how it comes into picture and how effectively we can utilize the features of fuzzy logic and how artificial intelligence will come into picture, I'll just tell you all the answers here. In a greenhouse controller, the outputs are taken into two forms. We have a water sprinkler and we have an electric roof in this case, right? So water sprinkler basically comes into picture when there is a requirement of water to the plants, and electric roof comes into picture when the solar radiation or the solar input has to be given to the plants. Now, how much solar radiation to be given and how much water to be given, this has to be controlled, right? So how do you control it? On the basis of these inputs received, that is the temperature, the humidity, and the solar radiation. Now what we'll be doing is we'll be utilizing all these factors, putting them through a fuzzy controller, designing it in the LabVIEW, and ensuring that the conventional on-off controller that is being utilized for this particular purpose is replaced. Also, the electric roof, which is being monitored. Again, it is monitored through on-off controller only. But how much roof to open, right? Now this has to be decided. So, because you have already seen the weather conditions are one of the most dynamic conditions that cannot be predicted correctly at all the points, right? So, because of this dynamic nature of this particular problem, the fuzzy logic plays an important role to solve this. Okay. So what we are trying to talk about is for the benefit of all those participants who are not knowing what we are referring to. We are referring to a greenhouse structure. Though we have already heard this name several times, this is a structure which is used to design or for the growth of plants and effectively growing good yield through these structures. Right? How do we do it? We do it by using the light and controlling the light intensity for the appropriate photosynthesis to happen. The temperature is controlled for the enzymes to grow. Humidity factor is controlled so that the growth of the plant doesn't affect to that extent. The carbon dioxide, very important factor for the growth of plant. The carbon dioxide control is there. Air movement definitely is required because this is a closed structure. Normally we see fields, open fields, so air can move in all the directions, but here the air movement needs to be controlled and the water and nutrients also need to be controlled. So being a closed structure, all these factors have to be taken into consideration, right? So these are the factors. Now few of the factors can be controlled by being present inside the greenhouse. Other factors, again, if you're not there and the dynamism of the weather comes into picture, then what happens? What to do? This was the motivation why we are designing this, right? So traditional control systems will be removed, will be taken care of, and we will remove this on-off system from this, which will ensure to save a lot of power for us, right? So as we already have seen the requirements of a greenhouse, here we were talking about all these things. This makes this system highly non-linear. And we are talking about highly non-linear systems, we are talking about highly complex systems also, right? So controlling all the variables together, we will be utilizing the features of fuzzy logic, right? So the on-off control system basically is replaced. It is once we work with those systems, you'll see we have some fluctuations, we have some actuator nodes, right, which comes into picture. We will be using the features of fuzzy logic to actually ensure that everything is smooth for a normal farmer also, right? So the fuzzy logic controller, the FLC, will be an effective medium to actually ensure that we reduce or we minimize the energy cost required for heating and ventilation as far as a greenhouse is concerned, right? So the objectives are pretty much clear. Now this is what you need to do for all the problems. That is why I'm trying to tell you, right? What you need to do is you need to design an intelligent controller. Now here, someone was asking how artificial intelligence would be. Because this will be an intelligent controller, AI would definitely come into picture, right? Now for greenhouse climate, how fuzzy logic and AI can work together, we'll just see. So to design the controller which is more efficient than what? Than the conventional controllers, and the one which consumes less power, very important, less power consumption, right? And it consumes less energy also in turn, right? So these are some of the objectives that we have kept in our mind before we design this. Now designing a dynamic controller, yes, because again I've already told you the environment or the structure that we are working with is very dynamic in nature. The weather conditions keep on changing drastically, dramatically at each point of time. So how to adapt, how this system adapts to these changing conditions, this is what we have to see. We've already highlighted this, we've already seen this, what happens. This is the data that we are getting now. This data will now be given through some sensors, right? Real-time sensors now. Sensors providing the data, fuzzification, rule base, the implication and the defuzzification done to produce this crisp. This is called as the crisp data, right? Now where is the greenhouse here? This is the greenhouse. So the sensors giving the input data, the actuators being controlled by inside this greenhouse, right? So this is what we have to do. We have to plan the system. Once the system planning is done, now you can actually work with the designing part. So you can work because we have seen some literature also. So here a few of the systems are working directly on conventional Boolean logic, the partial truth statements, right? Rule based decision making is done, right? So there are so many things that you can do. Literature has to be read. We have normally read this, right? So linguistic variables, rules, I've talked about this, right? So how cool is 36 degree F according to this chart? It can be, it is 30% cool, 70% freezing. Now there are so many intermediate values involved, right? I hope you're following this now. Now still it is 0 to 1. You can see this 0 to 1. Now you're getting this. How
Yes, sir.
cool is 36 degree Fahrenheit? So there are two values, right? There can be further values. How hot is this? They can write another question. How hot is, sorry, how hot is say 50 degree Fahrenheit in this case, right? So you can talk about this. There can be some more intermediate values here. So now all those intermediate values combined together will give you some rules, right? This is what we see. These are the membership values, right? Now how artificial intelligence comes into picture. This is the diagram. Have a look. Sensors, wireless sensors, or WSN as we call them, wireless sensor networks we can call them, right? So some sensors forming a cluster over here in a particular area. This is another cluster, this is another cluster, this is another cluster, so many clusters. They are communicating with each other through this base station, providing this data to a common system now. Now this common system will analyze this complete information, right? Now once this analyzes this complete information, it then transmits back to whom? To all these required structures, that is say a greenhouse, for example. That at this particular point of time, if you are located in this area, the temperature, humidity and other values would be accordingly like this, according to the data received. So this is real-time monitoring. Very interesting, very complex in nature and a very highlighted system, right? So what you normally talk about is, you talk about these kind of complex systems being worked through the usage of artificial intelligence, right? Now how do you do it? You do it accordingly, right? This is the flow diagram. Now you need to build this flow diagram in this structure. You design the greenhouse model in LabVIEW. I'll show you how to do it. You design this greenhouse control system, right? Using the fuzzy system designer, we have just seen this. We have to implement this controller for the greenhouse part, simulate it, and then see the optimized result. Do we get this? Yes. We'll see to it. We'll see to it how do we get it. So this is how it looks like. This is how it looks like. This is the front view. This is the front panel structure. If you see, what we have done is we have used different types of seasons over here: summer, spring, monsoon, and winter seasons. These are 4 seasons. Normally we get it. These are the inputs: the solar radiation in lux, temperature in degrees centigrade, humidity in a particular value, being monitored by different sensors. This is just a picture of a greenhouse. So you see the roof here, and you see these pipes. These pipes are basically these pipes are basically the points where we sprinkle some water, right? And this water sprinkling is done to ensure that the growth of plants is not hampered or not effectively monitored, right? So what we have is, we have an electric roof being controlled, and we have a water sprinkler being controlled. I hope you can see this. You can see this?
Yes, sir.
Right, great. So this is how it would look like. So there are some humidity values, there are some temperature values as we normally did. And when we'll move it, there are 2 types of systems that I'll show you. One where you can move or change the value of temperature, humidity and the solar radiation. And then the dynamic changes of this fuzzy controller will change the outputs accordingly, right? This is what we need to analyze over here. How do we analyze? How do we do it? How do we see the systems? Now I'll tell you all of the things together, how to create this. Just remove those arrows from the picture. Now this is the next part. We'll try and create some rules. I have used 27 rules for this particular problem, but you can use more also. The consequent of each rule is again based on if then else statement, and these are the tables. Again, I told you we need to formulate an ANDing table for this. Now, this is important. The solar radiation, temperature. Temperature is either cold, normal, or warm. Solar radiation is dark, medium, or light. Now, all this can be taken into consideration to formulate the rule. Can you see this? Semi-closed, moderate, less, very less. You just analyze this. Try to formulate a rule base for when humidity is dry. Now, you need to point out problems like this. Now, when humidity is normal, then what happens? Right, again the same structure, but with different outputs. You can see this output has changed here. And humidity is wet now. Right? Similarly, you can talk about other values. Right? You need to make this chart. You will see the output changes. While you specify the defuzzification method for this, and this is how it looks like. This is what we will design. Temperature, humidity, solar radiation. Output should be electric, roof, and water sprinkler. Right? Now this is the designing of the rule base, and this is the output as it would look like. Now I'm just moving out of this shell, and we'll design this practical system together. Right? We'll design this system together. I hope everybody can analyze this. So where we need to go? We need to go to tools, control design and simulation, and the fuzzy system designer would open for you. Right then, so we can work with this. Temperature, because it is greenhouse, so what we'll do is we'll take maximum temperature is 50 degree. I think that would work for us, right? And then temperature can be low, medium, high, moderate, right? So we need to specify. So as far as this table is concerned, just have a look over this table. So what type of temperature are we specifying? We are specifying three types: cold, normal, and warm. Right? So we'll take the same. Cold. Or say we'll start with warm first. So it will be easier for us. Warm. We'll take a triangular structure. We'll just change the color. Use some bright colors for this. So 40. Right? Is there some problem? I'm hearing some noise. Can you just let me know if there's some issues? Any problems? Am I still audible?
Yes, sir.
So I was just hearing some kind of noise, so I just thought that I'll ask you, is there any?
I think it's some disturbance, sir.
Okay, no problems. I'll again, for the benefit of everybody, I'll again just use this 0 to 50, right? And we'll add some membership function here. So it should be warm. Using a different color, 20, 50, 40, and then 30, right? And another value, warm. Medium. Trapezoidal function in this case. This blue color is bright blue would have right. So we start with the medium, means you can start with 40 over here. And, let it be 37.5. I don't mind this. So 20. Add another value, cold. Triangular function. So say 25. 15. Right?
Sir, can I see the values of that medium again, sir? Means values given for medium.
You can do it. You can do it on your own also. There is no problem. Just need to click onto this, right? Medium.
Okay,
These
sir.
arrows, right? You can use these arrows.
Yes, sir.
Also, what I'll do is now because we are familiar with the system, say in medium, I didn't like what I gave, so I can just do this also. Can you see this?
Yes, sir. We can alter it in the graph also.
Yes. And just alter it accordingly.
Sir, show me the next one, sir. That is code, I think, after medium. Next. Code. Okay, sir. You can continue, sir.
Right? So you can change it. You can change it accordingly. There is no problem here, right? So now this was temperature. The second part that we need to do is we need to use in this case is what? I'll just go back to the system again. Temperature, humidity, and solar radiation. These are three things. So humidity value, say it is from 0 to 10 only, right? Again, you need to select what humidity is. So we need to go back to the system to understand what we are talking about. What type of humidity are we talking about? Humidity is having three types of situations. One is normal, dry, and wet, right? So normal, dry, and wet. Wet means, again, I'm using a triangular function for this. I should always use a bright color so that it is visible. So we have 10 and 9 and 7. Maybe considered as a wet humidity. Then I need to add another one, normal. Again, use a triangular function for this system. I use green color so that it looks blue. Again, 8, 6, and 4 can be taken for this normal. Right. Again, I take this triangular function itself. I'm not changing it. I can use a blue color to distinguish it. So 6, 3, and 0. We get this now? Humidity, temperature, humidity. And the third case is solar radiation. Again, say I take it from 0 to 100. Now, what values have we taken for solar radiation? Dark, medium, and light. Right? So I added dark, medium, and light. So light means a lot of light is coming. I take a trapezoidal function for this sake. And change it to 85 and then change it to 60. Is somebody's mic on? I don't know. Right, so I've taken a light for this function, right? The next part is, again, you need to see light, medium, and dark. So medium means I should use it, right? 7, say we start with an 80, 60, and 40. Right? And then dark. Again, say I use a triangular function. And now I start with 30 over here, 30 over here, and 0. Right? So we use three types of values for temperature, humidity, and solar radiation. Now these are the three inputs. What are the outputs that you need to control? I hope you can answer this.
Sir,
what are the?
can you move a bit slow?
Sure. Temperature, humidity, and solar radiation. I hope everybody has done this.
Solar radiation. Okay, I'm just following.
No problem. So I'll just freeze the screen so you can see this. Just let me know when to move ahead, right?
Sir, we can just enter any values, right, sir? Means.
Yes. That is what I was just saying. We are just again trying to ensure that we are trying to build a system with what we feel would be comfortable enough for us to actually ensure.
But it would be better if there are some fixed values, sir, between both of us, so that the output remains same and we can discuss our.
So what you can do is you can see these values over here, right? What I'll do is I'll again show you.
No, sir. Means I got the point, but as it was pretty little fast, so I just said it.
No problem. I can again show you that. Temperature, warm is these values. Medium, I just selected randomly, so these are some values that you can see, right? And then cold, right?
Yes, sir.
Then we have humidity as wet. Wet means 7, 9, 10. Normal 4, 6, 8, and then we have taken dry as 0, 3, 6, right? Similarly, we have solar radiation with 3 values as light, medium, and dark, right?
Yes, sir.
I've still freezed it. You just let me know. So now you need to tell me because you finished this out. What are the output variables that we're talking about? Water sprinkler is one. Yes. What is the second one?
Electric
What is
roof.
this? Electric roof. Great. Right. Very good. Right. So
Sir,
we
how
need.
it comes under the output, sir? That electric roof.
It is electric roof comes under the output. Yes. See, I've shown you the system. Have a look over this system. If you see this greenhouse, the electric roof is made up of glass. Can you see this?
Yes, sir.
So the radiation would be either light, dark, or medium based on the opening of this glass. So there are
Okay.
controllers which either open this as you see in the window in your houses. If you open the window, the radiation is pretty bright, right? And if you close that window, the radiation is reduced. I hope you've seen that.
Yes, sir.
Right. So this is very similar to that. So this glass has
Sir,
to be.
do you have any short video of this so that we can understand?
Right now, not a video, but I can just a picture. But I can show you the working system in LabVIEW. Right. We will just see it how practically this is working for us. Right.
Yes, sir.
Right. So right now I don't have a video. Sorry for
Means
that.
it would be better for the understanding, sir. Just so.
I understand. I got your point, but right now, no, I don't have any video to support this. Right.
Okay, sir.
So, nevertheless, so there are two types of output variables. So, one is the water sprinkler. Water sprinkler over here. Say again, range can be specified by you people. Say I use it from 0 to 100, right? So, what range should I give it to? And again, we need to move back to the chart. Water sprinkler, right? It should be. It can be either moderate, semi-closed, closed, and you can use open also, but you can take 3. So it is moderate.
Sir, semi-closed is for electric roof.
You can use it for water sprinkler also, right? Not an issue.
Okay. Sir,
Right.
but we have water sprinkler categories as more, moderate, and less.
Less. Okay.
Less, more, moderate. So
You can
more
use
is
that.
the
So
highest.
we can use them moderate, more, and less, right? We can use 3.
Sir, another one is this, sir. Very less also.
Very less is also there. Oh, there can be another one very moderate, right? So again, whatever map you have designed, you can use those. So what we'll do is we'll use 4 of them. We'll use moderate, more, right? We'll use less and very less. I'll just show you how to do it.
So the order will be starting from more. Like more will be the
More.
highest.
Yeah. See,
Uh,
again, I'll tell you, there is no order. Let me tell you,
okay.
there is no order because you're doing graphical programming. Say in the middle, you just thought that what you'll do is you use less moderate also, right? So you need to just give the values. There is no serial order in this.
Okay.
Just to make
Okay.
it easier, I'm just taking it systematically. But there is no serial order in this case because this is graphical programming.
Okay, sir.
Right. As soon as you find out that yeah, I missed out on something, you can just implement it. That is the beauty of this particular graphical user interfacing, right? That it is providing us the flexibility that we can modify the system whenever and wherever we want. We just need not go back to that serial order to just see that whether that particular order is maintained or not. I hope we agree with this now.
Yes, sir.
Right. So again, we need to see. So water sprinkler more. Say trapezoidal function, right? So I use the value from 100, 90, and 80 over here, and then we can use a say 70 would be good, right? So this is more, more, then moderate, then less, right? So this is just to remember them. Moderate, a triangular function, change the color. And I start with 90, 50, 60, right? Or say you can use one 40. And I can change this to 70 also so that it looks much better. Moderate. Then add another one, less. Say 60 is the start. And,
Sir, means are we selecting the same shape for all the means?
you can. I'm just showing you so that it is easier for us to actually visualize the things, right? You can change the shape. I have changed it to Gaussian, no problem.
Means
Less.
will there be no problem, sir? Means we are choosing
See
different.
again. I'll tell you. There is no problem in selecting the shape. The point
Okay.
is, the point is, these are the inputs received in this particular fashion, and
Yes, sir.
we are specifying that this input is recognized by this kind of a membership function, effectively, right? So this is based on our own understanding. Now, once the membership functions have been designed, now the picture, the next part comes into picture. The min max, you have to select that, right? And on the basis of that, the shape that you have designed, the output value will be taken into consideration. Say, for example, I have now taken Gaussian function, right? You can see this for less. Now, if you see the intersection of this Gaussian function will be different from the triangular function. Can you see this change?
Yes, sir.
So this is what we need to see accordingly, which function suits us the best.
Actually, they are intersecting at the same point, I think, right, sir?
Because I haven't changed it, right? But still you'll see if I change it to Gaussian now and I'll add another variable to this, very less. Now you'll see what happens. Okay, very less is utilized. A triangular function is utilized, and I start with 30, 20, and 0. Can you see what has happened? There are three types of intersection at a particular point, right?
Yes, sir.
Happening. Now it is up to me to ensure what will be the best suited output for this kind of a structure. I don't know what has opened. Just move this out, right? So there can be a singleton line also utilized. So this particular thing actually comes into our structures only once we have thoroughly analyzed what kind of a system are we working with. right?
Yes, sir.
So the knowledge of that particular system is very important for us. So say for
Okay.
example, we have just used this, we have just used these four outputs. So you'll see the water sprinkler would look like something like this. So the next output would be what? Electric roof.
Yes, sir.
Electric roof over here, and we'll start, we'll give it a range as 0. Now, electric roof closed or semi-closed, right? So we'll use closed triangular function for us. Value of 10, 9, 1 and 8 for us. Right? Add another membership function. Semi-closed.
Sir, I did not get the values given, sir, for
You can use any of the values. I'll just show it to you, no problems. Right? A 9, 7, and a 5 for this. I'll just show you. You can see this. Closed.
okay, sir. 8, 9, 10.
Right? A simple structure I'm using. Semi-closed. And then add another one. Open. Okay, I'm using say I use a trapezoidal function for this so that you get the feel of all the functions in this. So we'll start with a 7 here, 5, let it be 2.5 and 0, right? So now if you see, you can see all the values over here. Can you see them? Now these inputs, again I'll tell you, these inputs can be given directly through sensors also. These inputs can be given after you've recorded the values from the sensors and give it to the system so that the database can be maintained, and if a certain kind of situation arises, that database can be utilized by it, right? So if you remember the slide, if you remember the slide that I've showed you in the very first place, knowledge base, rule base and database, there are three things involved in this. Now do you understand what I was trying to say by this? So we have a knowledge base, we have a rule base, and we have a database. You can take the information from either of the three. Now, just utilizing our tables should be designed. So we've already designed this water sprinkler and roof, and then now the next part is roof. Understand the rules?
Yes, sir.
So the easier part was pre-generate all the rules. We'll get it.
Yes, sir.
We got it?
No, sir. Just a minute.
Yeah.
Yes, sir. Got it.
You got all the rules, right? Otherwise,
Yes,
clear all of them. If you want to make it, see, add if temperature is warm, antecedent of temperature is humidity. Another antecedent that we want to use is solar radiation. Now you can see this. If temperature is warm, humidity is dry, solar radiation is medium, then the water sprinkler should be water, right? You can form this rule. I hope I was not that fast.
Sir, are the pre-defined rules means accurate or applicable for all the?
Yes. They are the best part, because this system now artificial intelligence is coming into picture. This is what I was trying to tell you.
Yes, sir.
Right. Pre-generated rules are generated on the basis of artificially intelligent system that is being utilized by fuzzy system designer.
Okay, sir.
Right.
Means it is all the data already pre-collected,
Yes.
analyzed, and
Yes. Now
applied.
see, again, I'll clear all these rules. Now if you see, variables are the things that I've just given to the system, right? And when I come to rules, it will ask me what do you want, what kind of structure you want, right? I need to give the structure. It is telling me 27 rules will be generated for 3 input variables. Are you ready for that? Yes, I am ready for this. I've generated this. I don't mind. Just read the rule. If temperature is warm, again, if you see temperature is warm, humidity is wet, solar radiation is light, the water sprinkler is more, and electric roof is closed. So if you want to add it manually, again, it is very simple. You add the rule first, you add the antecedents, and you add the consequent also over here. Then only the
Sir,
complete rule.
this will be a very complicated and lengthy process, sir. Means
No,
if
but no, this might be lengthy, this might be complex, but it will help you out understand the system better.
yeah,
I'm just
means
telling you. Yes, because
yes.
this is the one that you're doing it on your own. But if you want the intelligence to be used, it's very simple. I've already given you. Pre-generate all the rules. The rules will come. You've already done this. Just specify the defuzzification method that you want to use. Again, modified center of sums, center of sums. Now, somebody was asking what is the difference if we use these. Now, the difference will come in defuzzification method over here, right? All
Sir,
these
please
methods.
explain these 5D facilitation.
I don't have that much time, sir. It is already 12:40. If I start explaining all these methods, now this is the literature part that you need to read, right? So center of sums is something that you. I just explained one of those. If you can recall back, I'll just move
No,
to a slide.
means I just asked about the major difference between all the five, sir. Not
All are pretty different, so I cannot highlight. But this is one of the things that normally is done. Like you can see this line,
yes, sir.
right? So this is what is normally done. So you need to read this. I am sorry, but not enough time to explain all these methods. But there are formulas involved. You can read it from the literature. Not a big problem at all, right? So center of sums is very easy. Center of sums. So what you do is center of sums. You need to find out the center and them. Simple. Similarly, you have center of maximum or center of minimum, right? So, or say center of area. So the area of triangle can be found out easily, right? And then the center part. So the rules are so the defuzzification method is done on all these mathematical expressions that are normally inbuilt inside it, right? So once you have selected this, you move to the test system over here. Now, if you see again, what you have is two types of outputs: electric roof, water sprinkler, temperature.
Sir, we selected the center of area, right, sir? Defuzzification method.
Yes. I just selected center of area right now.
Okay, sir.
Right. Now, if you see, we have these outputs. The solar radiation also is there, right? So you can change them. Now, what we need to do is again the same thing that you did earlier. Right? Now you can see.
Sir,
Now you can see. Yes, please.
sir, why there are only two inputs that we can handle in the plot variable section? Like
Actually,
and only one output is given over there.
No. There are all the three given, but the only thing is that the scrolling has to be done. Yes.
Yes, sir. So we are not allowed to like.
No. Let me just tell you about this. Yes. See, as far as input variables are concerned, you can increase or decrease directly from there also, right? You can see this. This is just the slider option that is given here. Other than that, the best part is that you use this. Are you getting this? Alright. The slider is just an easier option for us, so we normally tend to use this. And in this also, there is output variable where the values are given here. You can see the values according to the temperature. They will be represented in the top corner. If you can see the change in values happening. Can you see this? Right. The only part is to make it easier, they have given a slider to us, right? And you can see, but this slider is of no use for us. Electric roof slider, not of no use, right? Though it can move, but the exact value is only shown here. If you can see that, right?
Yes,
Now
sir.
the type of rules that are the answers, the weights that you require are calculated accordingly. If you can see it, right? So you can keep the temperature moving. You can change the
Sir, we can
humidity.
just manually enter the temperature, humidity, and solar radiation and get both the outputs, right, sir?
That is what I'm doing. I'm doing it right now manually. You can see this. Can you see this?
Yes, sir.
I'm
Yes, sir.
doing it manually only, right?
Yes, sir. Means this is more applicable, but if
Yes.
you want to do it in an easy way, means we
So
can.
that is the easier way option, that you can use the slider. You can see the results, right?
Yes, sir.
Or you can see the values are depicted here only, right?
Yes, sir. Yes, sir.
And these are the outputs accordingly. So if the temperature is this, humidity is this, and the solar radiation is this, you can see all the values here. So what are the outputs? 4, 7, 13, and 16 are selected. Now you can see if I change the value, now 5, 8, 14, 17 is the answer. Now again, now this is based on artificially intelligent technique that we being utilized by the fuzzy system designer, right? You get this? Is it okay?
Yes, sir. Means
Sir,
the rules that are means designed, they were designed using AI.
AI, yes. The rules that were designed using AI, now the test system is behaving accordingly. Otherwise, the rules could have been designed on the basis of knowledge base also that you had, right?
Yes.
So now you got my point why I was talking that it is an AI technique.
Yes, sir. I got.
Great. Thank you very much. So what I'll do is I'll just now, because we are not having that much time there. So what I'll do is I'll show you a practical fuzzy system, greenhouse system, which it will be. This is the front panel right now, right? Also, just give me a second.
sir, did you exit? Means
Pardon me.
actually we can't see the screen, sir. Did you?
Oh. Just a second. I'll see to it. Just give me a minute. I think there is some problem here.
Yeah. Sure, sir. Sir, actually, we got the process flow and the concept, but how do we analyze it, sir? Means
Analyzing means what?
in the sense, means actually, right now we are not specific to numbers, but
Hmm.
when we are specific or under the case study, I think then analyzing comes to place, but not in this case. Okay, sir.
I'm sorry. I still didn't get you what you're trying to say.
Uh, Nothing, sir. Means just to analyze the design opting, that is by varying the inputs.
Oh, I'm just showing you the system. Just have a look. I'm just showing you the system right.
Okay,
Right.
okay.
So I'm showing you. This is not the one, but yes. Now have a look. Have a look over this system. Now here I've used the sliders. Right. So this is being controlled by me.
Temperature and humidity, yes, sir.
Right. I was just using that fuzzy system designer. Like I was controlling the temperature, humidity. Do you see that?
Yes, sir.
And I haven't used the solar radiation right now in this.
Yes, sir. I can't see solar radiation.
Yes, you cannot see it, right? So I haven't used this in this particular system design. But now you can. But what you can use see is the sliders. Now I'll run this system for you. You'll see. Say if the temperature is being changed, can you see the change in the output of electric roof and water spill? I'll just slowly change it. I hope you can see the change in the output values.
Yes, sir.
Yes,
So
sir.
the humidity was constant. Now I can change the humidity also, and as the humidity is changing, the water spills is also changing. Right?
Yes, sir.
Great. And now, if the season is changing, you can see the change happening.
Hmm.
All these are being
Yeah.
controlled through the fuzzy system designer that we have just utilized, right? So in spring season, we say temperature is this and this. So this is normal. But if the temperature increases, then what happens? Then the electric loop and water spill have to be changed, right? So this is a dynamic controller, basically based on the season, summer, spring, winter, the temperature and the humidity, but being controlled by us. We are getting some inputs and we are providing it to the system, and the system is behaving accordingly. Do you understand this?
Yes,
Yes,
sir.
sir.
Now I'll show you another system. Have a look. I'll show you another system over here. If you see, this is the system that we had been talking about. It is having 4 seasons. It is having the solar radiation, temperature, and humidity. But now there are no sliders. If you see,
Hmm. Yes, sir.
now this is getting data directly from the sensors, right?
Okay.
The sensors which are being plugged in to the system, they are providing the real-time data that this is the temperature right now, or say the wireless sensor network to which this system is connected is giving it an input that temperature is this, humidity is this, and solar radiation is this, right? Now I'll tell you how this behaves. So you can see I have connected it to some internal structure where the temperature and humidity keep on varying, and the solar radiation is also varying for us, right? Can you see
Yes, sir.
this? See this happening now? And if you see, I've connected some controls in the form of graph. So you can see that the input is given in this form: the water sprinkler, the electric grid, right? Uh, so if I change this value, the graphs would change and I can record them, right? Can you see that?
Yes, sir.
So right now, because the inputs are not being given directly, the electric loop and water sprinkler is not moving at all. Can you see this? I have to connect it to some sensors, and then only these outputs will be generated. So we are working on a practical system. This is the practical system that I'm trying to show you, right? So
Yes, sir.
we can give it an input of database also for the same sake, but system that we designed using the fuzzy system designer, this is the one. You have the sliders and you have the electric loop and water spill outputs, right?
Sir, are we creating this system now, sir? Means in LabVIEW?
Yes, 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 yes. So
Oh,
we have already created it. The point that rather using the fuzzy system design, see, I'll just show you. I've used the fuzzy this, using a MIMO system because we have multiple inputs and we are having multiple outputs also. And using is we are using the membership functions here, right? So what type of membership function you have selected have to be given over here. And lastly, we have a plot variable. So everything is there in the library that I showed you. Right? I hope you can. So if I'll go back to the control
Excuse me,
system
sir.
design, yes, please.
So, using the fuzzy system designer, we made all this through like predefined and everything we did.
Correct.
Okay.
Directly.
This is the system we have designed. Now, just like you have shown us in LabVIEW that we have a system running using those blocks and every controller and the
Right,
indicators and
right,
other functions.
right.
How can we do that? Like using fuzzy system designer, that's not possible. We have to like connect it and design it separately, right?
No, 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 no. You're confusing in that case. You see, using fuzzy system designer, the same input rules, same variables, and it as system output is shown directly here. The
Yes,
only
sir.
thing that you cannot do is you cannot just basically I'll tell you. Say if you have this kind of system structure, right? So it is just not showing you the block diagram configuration. Rest everything is being shown.
Hmm.
The fuzzy system designer is working perfectly in the similar fashion that this system is working. The only part is I cannot give input directly to this, right?
Okay. Yes, sir.
Now to
I cannot give a
go,
real-time input
yeah,
over here.
yeah. If you want to give,
What I am
you want,
trying to ask is, sir,
yes, please.
what I am trying to ask is
Uh,
that after designing this system, entire system,
right,
here we can see in LabVIEW there is a block diagram created like for your system that you have designed on your
right,
end.
right.
Okay. So how can I go from this fuzzy system designer part to that block diagram? Like for example, I would
Easy. It
say,
is
sir,
easy. That is
like
what I'm saying.
yesterday we did a image processing like this kind of example.
Right.
So we used the NI Max and there we used the vision acquisition add-on, and there we just gave the conditions for processing like this is processing should be done, and then we deployed it in LabVIEW, like convert it into a LabVIEW file. So when we opened that file, we got to see the block diagram and the controllers and the
Now
indicators and
this is very
all the other
similar. See,
functions.
have a look over this. What you need to do is again I'll tell you. So if you go to this toolkit, what you need to analyze is that is what I was saying in the beginning itself, right? Have a look over this toolkit.
Okay.
All the blocks are here. All the blocks that you require, if then else, the membership function, the variables, the fuzzy controller. Now what they
Yes.
have done is just the only thing that they have done in a fuzzy system is they've combined everything system. Right, and if you want to design this, it is not that understand is just need to understand the flow that you need to take input. If you need to take input, this is what has been written in the top. If you can see now, if you see Control H, you will see load fuzzy system VI. Right, I have to load this fuzzy system VI. I have to use some data. You can see the floppy disk also.
Oh.
Right. Now, once
Yes,
you're
sir.
done with this, you move to the another VI, which is called as a fuzzy controller. I just showed you this. So,
Yes,
fuzzy
sir.
controller will actually take the inputs and produce some outputs for you. Right. Now, these things have to be given to some membership, which you need to select. If I double click onto this, I'll show you how the membership function looks. This is how it looks like. Can you see this? Input variable, output variable, the fuzzy system output, right? If then else rule. Now, what membership function you have selected, inbuilt structure, you need to still select it. So, because there were 3 inputs, I took 3 membership functions, added them together. This is what we needed to do, right? Then we move on to another block over here where the implication is done. Then the defuzzification is done, and lastly, we get this out. Right? So, you have to just analyze the problem, place the blocks accordingly, and utilize the system. Now, if you are not very acquainted with this kind of a structure, because normally it looks a bit complex, so the easier option was an inbuilt fuzzy system designer which solves the problem for you. It is actually producing the required output for you to analyze the things. Once the analysis is done, you are pretty much clear that your problem that you're taking with the following data would produce this kind of an output, and this is the structure that you would require to build. Right? Now you can do it, you can save this structure and produce a similar kind of an panel structure, because there was not much time to show you how to produce this kind of a structure in the front panel. So I thought it will be easier for you to understand the fuzzy system designer effectively. But this can easily be built. There is no problem at all, right?
Okay, sir.
And if you want, what I can do is I can send you this VI also, right, with which you can work.
That will be
If you
good,
have,
sir.
if you have a reference VI, you will be able to design your own system on codes, right?
Yes, sir.
So there are you'll see in the examples, there are a few more examples which I would like to just share with you. We are trying about to just finish out the time. So this is one of the examples of AI-based parking system being designed. Fuzziness is being utilized for this. Now, if you see, there is a car that you can see. What I'll do is, I'll just run this for you, and you see, I place this card to this particular point, right? Can you see this? And I activate the fuzzy controller. As soon as I activate the fuzzy controller, the car is automatically parked in the garage. I move the position, I activate it again. You could see the change happening. The car
Sir,
will still
what
be.
actually are you changing, sir? Means.
I am just including the fuzzy controller inside it.
Okay.
Right? I've changed the position of the car here now. Now activate the fuzzy controller. I'm just activating it. Now the car is in motion because
Means it is actually automatically getting parked.
Yes. This is automatic parking using the fuzzy logic structure.
Sir,
Right?
how did you create all this? What is this system, sir?
No, this is basically an example inside the LabVIEW, but it is not that difficult to create these things, right? You can even change the orientation of the vehicle in this case, right? You can change the orientation.
Are we creating this type of system today, sir? Any
Uh,
small?
Basically, see, I had the time to just talk about the fuzzy controller for you, but if you want, we can definitely create these kind of systems also. I'll show you the backend. This is an example. You can see it, right? So again, that fuzzy control is being utilized in this case, right? Similarly, there is another example inside it. You can check the examples, right? You can find out this kind of a structure also, where it recognizes the shapes.
Okay, sir. It would be helpful if we create a small case study example today, sir.
Right now,
Of this kind.
see again, I have the time that I had just created the fuzzy system designer controller with you, right? So with these outputs, you can definitely analyze all the systems, but to work on see the practical systems that I'm trying to show you, these are some inbuilt examples of LabVIEW that you can see, right? You're in the help part, you write fuzzy and you'll get all these
Sir,
outputs.
from where are you opening these examples? Like which option?
From the help.
Acha, help. Okay.
Help. Fuzzy, find examples, right?
Sir,
Help
actually,
in.
yeah, go ahead, sir.
Sir, I didn't get it.
Find examples. Any example finder would open, and you can write different things over here, right?
Okay, got it, sir.
Got it? And then you'll see.
Sir, as we just designed through this fuzzy system designer, the outputs we have got are this about wait and invoked rule. How we will use this further, sir?
I didn't get. How will we use this as?
How will we use this further, sir? Means you said this is the output. Means invoked rule and wait. Actually, I did not get the point.
See. Again, there was a problem. The problem was that these are the inputs, and these outputs have to be controlled, right?
Yes, sir.
So for that, we formulated some rule base.
Yes, sir.
and then we tested our system that if the temperature is this, humidity is this, solar radiation is this, what is the output of the water sprinkler and electric group?
Okay, just the data interpretation.
Yes, this is data interpretation done through Fuzzy System Designer. Now, if you want to use it, you can save this, use it as a sub VI, and use it in your system, right?
Yeah, now I got the point, sir.
Okay, that's it. Thank you very
Yeah.
much.
Naveen, now this the beauty of the LabVIEW that you can integrate, you can capture the data real time. So like you are giving that temperature and that inputs, na? So you can
Uh,
call those inputs to the DAC. Yesterday we have shown you how to call the inputs to the DAC to some channel,
yes, sir.
and then the processing will be happening in the real time. So
Yes, sir.
presently, what you are doing, you are taking some variable. But if you'll define that variable through DAC, if you'll capture those variables to the DAC, then it will become a real-time system where all the things will be happening in real time.
Sure,
And
sir.
this
I
is
got the point, sir.
and this is to introduce you that beauty of the LabVIEW. It's so easy and so much useful to you, all of you.
Yes, sir. Got the point, sir.
I
Thank you.
think, Nikhil sir, when you have shown them the last thing, they would like to extend the sessions. I could guess that now this Nikhil is very much he's planning for one more day. That
But sir, actually, I have my commitments after 2 p.m. There are a few meetings that I
yes,
need to
yes,
work out. So I'm sorry for this, but nevertheless, again, sir, there is because I've shown them the examples are there, right? And they can just first copy those examples and work in those examples, and then modify them.
actually,
Sir, actually,
Naveen, this workshop is to means want to give you that applications and make you practice, and then there is no end of exploration, right? You can means now you must be having some idea that how you can use LabVIEW in your own engineering applications, yes or
So,
no?
I'll just add to this what you have said, sir. We have a full USRP available with us. I don't know how many of you know that term. This is a universal synchronous asynchronous receiver transceiver peripheral, right? So the that particular USRP device can solve all your communication problems. There is another toolkit, new toolkit added by LabVIEW, where you can interface Arduino directly with it.
We have done yesterday on
Yes,
day
sir.
before
Sir, we
yesterday,
have done
na,
it
on Arduino we
yesterday,
did.
sir.
Right.
Yesterday or day
So,
after, day before yesterday, sir.
Yes,
Actually.
sir, sir.
amazing.
So there are so many things. Even Internet of Things IoT toolkit has been added. So I haven't seen it because I am using a older version, because this is not a cracked version and I am having a license for this, right? So I have installed this and I'm using it. But there are a few more toolkits. Another interesting toolkit that I have started working on is biomedical, right? And if I tell you, it is one of the most interesting toolkits to be utilized for biomedical synthesis. So, see, there is no end to this. The point is that if you are familiar with this kind of an environment, how to utilize the graphical features, right? It will become very easy for you to understand the problem, formulate it in a graphical design, and it is not necessarily that you should you design it very effectively, right? This is the beauty about the software. You can be very haphazard in your design, but still the problem is solved. Now I'll tell you why I took this. Is see the output values in different fractions. Can you see them? Won't get it anywhere in any software. Now this can be given directly for monitoring the database, also can be utilized for some, say you are getting some real-time inputs of a temperature, right? So temperature will not vary say in an hour or so. So it is 1.30 point something, right? You can actually use this effectively. I hope you get this, right?
Yes, sir. Sir, I just want to say one point.
Please, please, please.
Actually, data interpretation was the objective of this designing the fuzzy system, and we did
Right,
it.
right.
The point where we got confused was you just suddenly jumped to that examples. Means
Oh, okay.
so
I was just trying to show you those examples so that you are familiar with the toolkit, and if you want to practice, you can go to those examples and see it for your own.
yes, sir. But as we were just creating, we means
So
we
it is
were
not that
thinking about how
yeah,
from where this came and how
it is not
we
that
did
easy
it
to create
and
those examples.
how
Again,
we
I'll
can
tell
do
you,
it. That was
it is
running
not
in the
that
mind, sir.
it is not that easy to create those examples easily. But if you start practicing with the fuzzy system designer, you will be able to do it. Right? There are tutorials available after this also, and
Yes, sir.
you can
That's where
definitely
we
use it.
got confused.
So, but I hope you have understood how to use the FSD.
Yeah, sir. Definitely.
So, if you have understood that, it will solve all your fuzzy problems effectively. And you can even get the results published because you are working with some database which you will collect from either from some real-time source or from some source which is actually monitoring that data effectively, right? You can get the data and analyze it and produce the output results according to the system that you use, right?
Yes, sir.
Right, sir. So that's it from my side, sir.
Yes, thank you so much, sir. Nikhil, sir. The session was very good. I myself am attending all the session, sitting
That's
here,
great.
and you know that our audience is great. They are attending all the sessions. You'll be surprised to know that in the last 3.5 days, we have taught them 3 hours more in the online mode.
Great, sir.
Generally, in the online mode, it comes less, but we have exceeded our session timing on the day one, half an hour, on the day two, 1 hour, and yesterday it was 1.5 hours. So that you can see the enthusiasm among all the students, and it's very nice. And the same enthusiasm continued today also, even on the working day, na? After that Sunday, Saturday, Sunday.
Right, sir.
Nice, very nice. We, on behalf of everyone, we would like to thank you, and we hope to continue again some more discussion on the same on these
Sure,
things.
sure, sir, sure. And I would like to appreciate all the people who have attended this particular workshop. I'm thankful for everyone who have asked the questions, listened. It actually says that we are listening and following the things clearly, sir. So I'm very thankful to everyone, sir.
Thank you, sir.
Thank you
Thank
very
you
much.
all. Yes, sir.
Thank you very much to you, sir. You have taken a lot of pain to design this course and call the speakers from all the various fields to ensure that they get the flavor of everything. So this is one of the most best thing that you could have done for the audience that you are having. So I'm very grateful and thankful to you, sir.
Yes, sir. Actually, that is we have a team of Dr. Gunjan Soni, Dr. Amit Singh. I have long association with them. We were
Right, sir.
colleagues, Bits Pilani also.
Great, sir.
Unfortunately, when we are being mentored by MNIT Jaipur, and we have the same that we have opportunity again to work together.
Great, great,
So,
great.
yes, so thank you everyone. Thank you again, Nikhil sir. Thank you all
Thank
the
you, sir.
participants. So at 2:30 p.m. we'll be meeting for Dr. Naresh Raghuvanshi
आपने माइक्रोवेव के सब्जेक्ट की
from
थ्रेड
the
मेरे को भेज दिया मैं आपको पढ़ाता ही हूँ
department, uh, Mechanical Engineering Department of MNIT Jaipur. So he will be giving lecture on condition monitoring of the systems. So all of you kindly attend. It will be quite informative. Thank you.
Right, sir. I'll take your leave. Thank you very much, sir.
Yes, sir. Yes, sir. Bye, sir.
Bye, sir. Bye, sir. Thank you very much.
Thank you, sir.